Right, this video is going to go through the basics of equivalent fractions and a simple kind of problem you may get that involves them. So I'm starting with a diagram here which is showing the fraction a half because one out of the two sections are shaded, and that's how it would basically look. Now if I wanted to show what an equivalent fraction would be to a half, I'm going to change the diagram so that I've split it into 4 equal parts now. And the fraction that's shaded this time could still be a half, but I could also write it as the fraction 2/4. Now the fractions a half and 2/4 are what we would call equivalent. That means they're equal because they both represent the same shaded part of the diagram. So nothing has actually changed in the diagram, nothing more has got coloured in, but I can use a different fraction. Now the diagram could be split in a number of ways. As long as I don't shade any more in and I keep all the little parts of the diagram equal in size, then I will get equivalent fractions. So I could split it like this and get 4/8, or I could split it like this and have 8/16. And there are lots of ways I could do this. So here I've got those 4 fractions I've mentioned lined up, and there are lots of patterns that people could spot. Some of these patterns are nice things to spot, but they're not actually that important sometimes to fractions, and particularly equivalent ones. So I'm going to pick out 2 of the fractions. I'm going to pick a half and 4/8, and I'm going to see how they are connected. So I'm going to get rid of the others and look at the numbers in these fractions, particularly how the numerators have changed and the denominators. So how could I change the number 1 into 4 and the number 2 into 8? Well, a simple rule that would actually do that is to multiply by 4. And so equivalent fractions can be found or problem solved by looking for a number we can multiply both numerator and denominator by to get to a solution. If we were dividing, that would be simplifying fractions, but still creates equivalent fractions, so it can be solved in more than one way. So let's look at a simple problem that we could get on this. Here we've got the fraction 2/7, and we're being told it's equivalent or equal to another fraction where the denominator is 35 and you've got to work out what the numerator is. To solve these problems, you look at which pair of numerators or denominators you know. So we know both denominators, and we're looking for how we could get from 7 to 35 through multiplication. So to get from 7 to 35, well, you'd have to multiply by 5. Now, taking that rule of what's happening with the denominators, use the same rule with the numerator. So the 2 will get multiplied by 5, and so the numerator will be 10. And so 2/7 is equal to 10 over 35. We could check this by simplifying 10 over 35 and make sure it gets us back to 2/7. Yet, if we're confident that we found what we're multiplying by, that may not be necessary. And the more you practice with this, the less likely you'll come across any mistakes. So I hope this has been helpful. Feel free to leave comments and things, and hopefully this will help you go on and use equivalent fractions, particularly at some of the higher level stages like adding and subtracting fractions. Thank you.